We used 118 of these Lego pieces to build the task spot used in the exercise's measured turns and full speed ahead. In the measured turns exercise, we used the task spot with the pen attachment to trace different angled circles. In the exercise full speed ahead, we learned how to program the task spot so both the motors run at the same time.
In DMH forward, we programmed our robot to go forward. This block tells motor C to go forward, and this block tells motor B to go forward. They're the same, but they tell different motors what to do. This block is a wait for block, and it tells each motor to wait 720 motor degrees rotations before stopping. And this block tells motor C to stop, that block tells motor B to stop. This is DMH forward in action. These are combination blocks that combine 3 blocks into one. For example, this tells both motors to go forward 10,042 motor degrees before this block tells them to stop. This block tells motor C to go backwards 420 degrees before both of them stop, thus turning the robot. To find how many motor degrees it takes for your robot to go forward, a certain amount of inches or centimeters, I use this strategy. Say you want your robot to go forward 40 centimeters, and the circumference, the distance around your wheel, is 10. Wouldn't one rotation take you 10 centimeters forward then? So if you take 40 centimeters divided by 10, it's 4 rotations. To find the circumference of a circle, you can draw 2 lines from each side of your triangle, or each side of your circle, and then pretend there's a string there, and put your pencil on the end of it, and draw a line here and here. And also do the same with this side of the line. So that would draw this line and this line. Then you take a ruler and draw a line through those 2 points where they meet, and do the same with this chord over here. That's what you call. That way you find the center of your circle, therefore you can find the diameter and take that times pi, and that gives you the circumference. Say you want your robot to turn 90 degrees. Well, you put 90 degrees over 360, which simplifies out to 0.25, and we want to find the distance traveled. The circumference of the trace circle, and that equals the distance traveled over the circumference of the trace circle. So let's just say the circumference of the trace circle is 27. So to get the variable by itself, which is distance traveled, take that times 27 over 1. Also take this times 27 over 1. That gives you the distance traveled. The distance traveled by the wheel equals the wheel circumference times the number of rotations. To get the variable by itself, you take the wheel circumference divided by the wheel circumference, and also take this divided by the wheel circumference, and that gives you the number of rotations. Take that times 360 to get the number of degrees your robot wheel has to turn to get 90 degrees.
In this segment, we have learned to collaborate very well with Dawson Hayden Brighten and Hayden Brighten. We have a very strong collaboration in our group, and this is an example of
Go.
nice save.